My name is Christopher Swenson. I'm an engineer on the Vault team at HashiCorp, and I'm here to talk about building Vault plugins. A quick outline, I wanted to talk a little bit about why we were doing this, a bit about how these plugins work under the hood using Go plugin, and then I'll dive into the main topics, which include talking about different Vault plugin types, and then how Vault plugins work in general, talk about the plugin lifecycle, and then go into a bunch of best practices and show some example code on how to build your own plugins. So what is this about? This is about building plugins for HashiCorp Vault. The reason you might want to do this is that Vault supports a bunch of external systems out of the box, things like AWS and Google and Azure, but obviously can't integrate with everything. So you may need to build your own plugin to integrate with another system that you care about, like a system that you work with. Or maybe you need some capabilities that aren't possible with the base Vault, like using CGO to access C libraries for an external system. Or maybe you want to make changes to an existing plugin to add functionality that you care about. And just before we get into too much about Vault specific stuff, I wanted to discuss a little bit about plugins under the hood. So Vault is built in Go, and Vault plugins are all based on Go plugin. Basically, Go plugin works by separating out a plugin into its own binary, so that means it runs its own main function. This allows it to have much stronger independence from the main Vault binary. So Vault itself, whatever the prepackaged code is, but you can, provide your own plugins that can do various tasks. And they don't have to be built into Vault at compile time. They can be specified at runtime, and they're run as their own separate binaries. They communicate over RPC. This means that there's no dynamic linking required. So we'll quickly go over how Go plugin works. It kind of elaborates on what I just sort of talked about. But basically, whenever Vault wants to load a plugin, your program, in this case Vault, it starts up a Go plugin client, and this has to specify the location of the plugin executable. So this will be the location of your plugin binary. And then that goes ahead and starts up the plugin in a separate process. That plugin is expected to start up the Go plugin server. And the Go plugin server does a bunch of initialization, and then it writes to standard out saying, this is the version I support, here's the protocol, here's how to contact me for gRPC purposes or netRPC purposes, and then maybe a certificate about how to securely communicate with it. And now the client has enough information from that standard out line to connect to the server that the plugin is running. And so now they can start communicating over RPC using either netRPC or gRPC. Generally, this is going to happen over a Unix domain socket, this connection that they establish, but it can also use TCP for systems like Windows that don't support Unix domain sockets as easily. I just wanted to run through a quick code example. I like seeing things in code to see exactly what's going on so that there's no magic happening here. This is what any kind of Go plugin main is going to look like. This is not Vault specific, but you have the core of it really is this plugin.serve. So Go plugin.serve, and you tell it what you're going to serve. It needs a handshake config. This just tells it how to identify itself essentially with that it knows it's running in the correct environment, that it's your system that's asking it to run. You're going to specify what plugins that you're going to provide implementations of. This means basically what protocols are you going to support? I'm going to implement a particular plugin for Vault. What are all the names of them going to be? And then that needs to point to some sort of implementation that tells it how to run those methods. And then a gRPC server in this case, since we want to communicate over gRPC. On the other side, the program that wants to load a plugin, in this case something like Vault, the way it would start that process is it creates a client. And it says, again, this handshake config, this says I'm going to set basically things like certain environment variables so that the plugin knows that I'm the one talking to it. What plugins I want to be able to fetch from that plugin. Maybe it contains multiple implementations or multiple plugins. how to find the executable itself. So typically this is just location of the binary, but maybe you have some sort of wrappers for various other ways to access it or load it. And then any protocols allowed, meaning netRPC or gRPC. Generally we use, again, gRPC. So after you've created the client, you start it up, and then you ask it to dispense the actual implementation that you're interested in, the actual plugin, and then now you can basically cast that to the plugin interface that you want and start accessing its methods, and then those will be transparently called over gRPC. And it's mostly as simple as that. There's a few pieces that we're not delving into, like the specifics on how these plugin interfaces work, but they work in a rather standard way. Now getting into Vault specifics, Vault is built on this entire framework, but it provides a bunch of interfaces and helper structs to make this a little bit easier, so you don't have to worry too much about these details like handshakes and this plugin map and things like that. For the most part, you can just build with this sort of template in mind, and Vault will know how to use your plugin already. So yeah, a fun fact is that Vault is itself using all of these plugins internally as well as externally to provide most of its capabilities. So Vault itself, has a core set of capabilities around things like leases and policies, but most of the functionality that talks to external systems or provides storage and things is often built on this plugin system. There are 3 plugin types, and we'll talk about each of them. There are secrets engines, and I'll go into the differences in just a second, auth methods, and then database plugins. So secrets engines are the most general type of plugin, and these are typically used to either store information or generate secret information. So static secrets, typically things that are stored and live a long time, or dynamic secrets are more short-lived things. So I'll give some quick examples. We have the KV secrets engine is probably one of our most popular ones, and it is implemented as a plugin secret engine. And this just provides generic object storage, essentially, that can be used to store secrets as just arbitrary JSON objects. The secrets engine can also be used to generate dynamic AWS access keys, for instance. So if you have an AWS role, you can load in enough information into the Vault secrets AWS plugin and have it generate access keys that are short-lived. You can also have, you can use the PKI secrets engine to generate entire PKI infrastructure like CAs and certificates. So really, secrets engines they're really very generic, but they're meant to store secrets or generate secrets and return them. The other plugin type you see most often probably is an auth method. And an auth method is designed to allow Vault to be able to validate third-party credentials. So essentially, they turn external credentials, like AWS credentials, for instance, into Vault tokens that can then be used to access the Vault API. This means that you can have someone authenticate, say, they're a program running on an AWS instance, and they can access the AWS IAM instance profile, call out to Vault, and turn their IAM profile into a Vault token that they can then, say, access some secrets that are stored in Vault. Ditto Kubernetes, you can have, say, a Kubernetes service account that has access to Vault, things stored in Vault, and we would use the Vault plugin Auth Kubernetes plugin to turn those service account tokens into Vault tokens, which can then access Vault resources. JOT and OIDC is another very popular auth method. So you can basically take any JOT and specify what it looks like and where it comes from, and be able to turn those into Vault tokens. Keep in mind that whenever we talk about secret engines and auth methods, the kind of key flow is that auth methods, again, is something that takes a credential. So you make an API call, here's my credential, and the auth method has some way of validating that and returning a Vault token. And a secret engine, on the other hand, though, takes that Vault token with standard Vault API call with that token as say, a header, and then it can return a secret, or store a secret, or delete a secret, or whatever. But generally, it turns tokens into secrets, whereas the auth method turns credentials, external credentials, into tokens. The third kind of plugin that we see a lot is database plugins. So these are used in turn with the database secrets engine. So this is a super secrets engine that's built into Vault, and this allows you to work in a slightly different way than the previous ones do. They turn Vault tokens into database credentials. So it's basically a special type of secret engine where the secrets are going to be database credentials that are returned. And so it standardizes a lot of the logic inside this database secrets engine so that you can write a much simpler plugin that does all of the Vaulty stuff already, since it's basically the same for, almost every database. You'd want to have the same sort of Vault logic. And you want to basically just plug in, okay, here's how to create a user, here's how to delete a user. So let's get a little bit into the mechanics of plugins themselves. So if you want to use a plugin in Vault, it's relatively straightforward. It has a few steps. The first is that you have to tell Vault how to find the plugins. So this means it has to be started with a plugin dir argument, or as part of its configuration, there's a plugin directory in the config, the HCL config. Once that's started up, you can copy the plugin and set permissions into that directory. So copy your plugin binary into that directory, and then set any permissions to make sure that the Vault user can, read it. Once the plugin is ready and Vault is running, you can register the plugin. So this requires you to specify the plugin type, like secret or auth, and then your plugin, so the actual plugin binary inside that plugin directory specified earlier. And you do have to specify the SHA-256 of the plugin, just so that we know that nothing weird is going on where you're trying to register a plugin, but somehow it's been swapped out under the hood with a malicious plugin. So you have to acknowledge via the SHA-256 that this is the plugin that I want to register. And then once it's registered, this only has to happen one time, and then you can use the plugin a bunch of times and mount it a bunch of times inside Vault using Vault Secrets Enable or Vault Auth Enable. Are the two primary ways for secrets engine and auth methods. So this way you can, register my KV plugin, for instance, and then enable it at a bunch of separate paths. And maybe those paths have, different permissions. They'll all have different storage under the hood. With a database plugin, that has to be done in a slightly separate way by, you would have to have already done Vault Secret Enable Database to enable the database plugin. The main database plugin, that is. And then your individual plugin will be used when you write a configuration to the database system and say, I want to use my plugin with this particular configuration to access, say, a MySQL database or an Oracle database. If that seems like a lot, sometimes when you're doing development, you don't want to necessarily go through all of this, and you can use Vault Server dev plugin dir. And dev plugin dir allows you to specify that everything in this directory is going to be plugins and go ahead and just automatically register them whenever Vault starts up. So this allows you to sort of skip this step. It just reduces a little bit of the toil whenever booting up Vault and doing a bunch of plugin testing. So nice, handy method there that we use when developing plugins. So let's talk about plugins themselves. So what does a plugin look like code-wise? So typically we like to structure ours this way. This isn't, there's no hard and fast rules to how it looks. As long as you have a plugin main that looks kind of how we're going to show, then it will work. But in general, we like to put our main inside a CMD folder. And this is a sort of standard Go practice for how you, where you put your main functions. But we want to say the main goes in there and that only contains the main. Typically, you'll have the backend for your plugin, the actual piece that has all the storage and does all the work inside a backend.go, and then any individual paths that you expose for the plugin, like API paths that people can call, will be listed under path underscore and then whatever operation that is. In general, the logical.backend plugin interface is the key Vault plugin interface that everything has to follow. But we fortunately don't have to work with this directly too often. Most of our plugins, I think every single one of our plugins uses a higher level abstraction over this, which I'll talk about shortly. But technically, under the hood, every Vault plugin looks like this. It has some initialization stuff that happens over here on this left path. But for the most part, whenever almost all of the work is done in these three methods here: handle request, invalidate key, and handle existence check. And those handle all of the HTTP requests for your plugin and do most of the work. But this is a little abstract, and it's a little low level in terms of HTTP. So you're handling like raw requests there. So in general, we typically use the SDK framework. So rather than having to work with logical.backend itself and having to deal with all of this plumbing ourselves, if you use SDK framework.backend, this is a struct that you can mix into your plugin and have it handle all of the HTTP logic for you, so that you can use a more path-oriented way. So saying, instead of handle this HTTP request and have to parse it yourself, you say any HTTP request that comes in this path, which maybe has regular expressions and whatnot on it, I want to map it to this Go function. And then the framework.backend core will sort of handle all the HTTP routing. So what does a plugin typically look like in Vault? It's sort of built on what we saw earlier, but it's a little more specialized to Vault. So our main typically calls plugin.serveMultiplex. This is a Go plugin method. And I'll talk a little bit about multiplexing in a bit. And this has to map to a factory function. And the factory function typically just creates your plugin. So it does whatever initialization is needed to create an instance of your plugin specifically. And then that usually will boot up a framework.backend, initialize that, and call setup. And then this is where, whenever creating that framework.backend is when your plugin sets all the paths that it's going to respond to, any like cleanup functions, any help. So if you're going to show any like help text when someone queries about your plugin, you put it there. And then after the factory creates your plugin, the initialization function is called, if there is one. And then you go into your main loop, and this is where requests are basically just handled automatically by the framework.backend. Each request will then be passed to the correct path in your plugin and calls the appropriate Go function. If you have a periodic func, that will also be called occasionally. So this is where you can do any cleanup work that your plugin might need, or maybe you need to do some maintenance on your storage and whatnot. That would be done through a periodic func. And then finally, when the plugin is shut down, the clean function will be called. So this typically looks something like this for the main. You have this sort of just generic setup for doing some flag parsing. You call plugin.serveMultiplex, like we mentioned before, and tell it where to find new instances of your plugin. And that's it. Really, the core differentiator between all plugins is this line right here that says this plugin uses this factory. This factory, like I said, is the main differentiator between different kinds of functions. And it basically is any function that can return a logical.backend. But they typically have a sort of standard structure to them, at least in our plugins. So first off, we're going to want to be returning our backend for the plugin, meaning the actual plugin itself that does all of the work. And so our factory function typically is as simple as go ahead and create one of these backends, populate the framework.backend with some information, things like what kind of plugin type am I? Logical means secrets engine in this case. What kind of help am I going to be providing? Help text for people who might be requesting more information about your plugin. And then really the key is the paths. So this just says this is a list of all the paths for every operation that I'm going to be providing. And we typically specify those separately in separate functions, since they tend to go into a lot of details about all the parameters and path arguments and whatnot. It's important we call setup before returning. This is just an implementation quirk that the factory is responsible for calling setup. And then we return. And that's really the core of it. Any other initialization you want to do would happen in here if you needed to, set up some keys or, maybe initiate communication with some other system if you have enough information to do that. One key point here that I wanted to mention is typically when you're working with inside the factory and inside the setup, you do get access to storage, meaning you get a view into Vault storage to do some initialization if you need to, and that will give you a storage view implementation to do that. But you don't want to save that. So in general, that storage view is not going to be valid after this finishes up. And so it's dangerous to hold on to that and try to do things on your own behind the scenes, for instance. That's what the periodic func is called. I mentioned this earlier, but essentially you can say every now and then I need to do some periodic work. That will allow you to access storage through the request it passes in. So that way you don't need to hold on to the storage view from the factory or the setup methods. You can use the periodic func to do any cleanup or other maintenance you need to do. So the actual paths themselves, these are the pieces that implement any endpoints that your plugin is going to let people use. These are all exposed through framework.paths, and they're given back again in the factory in this part here. So each of these goes into basically a bunch of details about what kind of pattern are we going to match. So what does the path look like? In this case, maybe it's something as simple as config/keys, but if you had maybe multiple keys and you wanted to use a regular expression, you can add that here. Framework even has some additional methods you can call that help you sort of build these strings. Fields are anything that you want to allow as in the request. So if the request has some certain input that's required, you can specify what that input looks like here. And then you specify what the actual operations are. So anytime I get a read, call this method. And you can specify some additional information about like what parameters you might return and what those look like as well here. But the key really here is pattern here, and then operation, go function. The actual framework operation itself is just kind of straightforward Go code. It needs to be a function that takes in a context and a request and returns any kind of data. This will be serialized to the user and an error, of course. And these typically in plugins follow a sort of standard pattern for a read. Grab something from storage related to the request. Also worth noting, as a convention, any data in Vault storage is JSON encoded. This isn't a strict requirement, but we usually follow this pattern. So typically anytime you fetch anything from storage, you immediately decode it as JSON. And maybe you do some other manipulations or generate new data and then finally return that to the user. And then this will get serialized to the user as JSON as well. Replication, luckily, so since Vault does have high availability and can be running a complex cluster, you need to worry a little bit about replication. Luckily, this is mostly handled for you when you use the SDK framework.backend. But there is a key that you do need to implement. If an error does occur and storage has to be rolled back for some reason, it will call the wall rollback function, the write ahead log rollback function. And this will give you information about any data that was rolled back. So if you, say, need to synchronize with an external system to delete a user that was created as side effect, then you can do that in your wall rollback func. And there's some tuning parameters you can provide about how often this occurs or what the timeouts are and things like that. Roles. So here's an interesting thing. If you've played around with the Vault, you've probably seen roles pop up a lot. Interestingly, Vault itself doesn't have an internal concept of a role. It only has policies. And plugins define what roles mean to them. We have some kind of loose guidelines that about what roles mean in various contexts. So, for example, if you're an auth method, then the Vault role is typically mapped to the Auth Methods credentials, and then that's mapped to policies that they allow the use of. This way you have essentially a layer of indirection, and and making it use RBAC, so role-based access control. So this way your credentials aren't mapped directly to the policies, they're mapped through these roles. And allows you to modify the roles independently, and then this way they're not so tightly mapped. It makes it just in general a lot easier to work with. On the other hand, for like a secrets engine, this might mean the vault roles are mapped to, say, AWS credentials generated for that. So you set up a role in the AWS plugin and have that, say, mapped to a set of credentials, and you might have access to that role to generate those credentials. So it sort of flips that on its head a little bit. And sometimes they're used in just totally different ways, like in KMIP, the KMIP secrets engine, which is used for certain other kinds of interoperability with other systems. The roles are mapped to a certificate key pair, so used to authenticate, and that is mapped to a scope, which essentially is just like an isolated chunk of that KMIP instance for storage. So not really quite in the traditional policies sense, but it has its own kind of concept of roles. So it's up to your plugin what roles mean to you, but it's probably for the best and will confuse users the least if they sort of map to, say, how the standard plugins use roles and have similar methods. So I definitely encourage you to sort of work with those as closely as possible. Policies. Typically, the policies are not explicitly set or used by plugins, but you use them to access the plugin endpoints themselves. So any of those endpoints that you expose via your framework paths, the user needs to have access to those. And so policies are still are used by Vault to enforce that. So these are just the standard Vault policies, checked against the auth token of whoever is calling that API endpoint. The sort of exception is the Vault auth methods can cause tokens to be issued, against roles and therefore policies, and then those are bound to those policies. So since they can generate Vault tokens, they do interact with policies a little bit more. Multiplexing. So I didn't talk about this too much, but you might have noticed we were using serve multiplex. You can just use serve instead. The key is if you use serve multiplex, Vault will try to use a single instance of the plugin per namespace instead of multiple ones if you mount it multiple times. This can have a bunch of benefits if you're running only a single instance. Notably, if you're running hundreds of mounts of this plugin, for say a very large deployment, hundreds or thousands of them, or hundreds, then that will save you a ton of memory and a ton of process space. So where you're running only a single instance instead of multiple, and also can just in general make things more efficient. We do know that there are some cases where you just really want to have that extra process isolation. So serve is still supported, but definitely we encourage serve multiplex by default. I want to wrap up with a few just best practices, for writing your own plugins. The first best practice is, of course, to look at existing plugins to see what they're doing. The HashiCorp plugins, there's about 40 or 50 of them that you can look at. So a few quick examples of each are Vault plugin Secrets KV. This is sort of one of our gold standards, our most popular plugin. It's built into Vault, but it's developed in a separate repository that can also be used as a standard external plugin. The Auth plugin example, unfortunately named that the Auth plugin is swapped there for some reason, but it has just a very basic auth method that you can look at for inspiration. And then for a database plugin, you can look at one like, say, MongoDB Atlas, or even there's also an Oracle plugin and a bunch of others that are good ones to kind of model on how they structure their code and whatnot. And they don't actually follow all of the guidelines and structure that we mentioned before, but they do a pretty good job, and we've been working with them for many years and try to keep them up to date. So a few other tips: definitely use the initialize func and periodic func and close methods. Don't try to roll your own cron-like functionality where you say spin up Go routines and sleep and stuff like that, you'll run into problems with the storage views maybe not being valid whenever you try to run later. So, and we really encourage using things like periodic func and initialize func to deal with any of that, to deal with any periodic maintenance needed or initialization. Again, use serve multiplex instead of serve. There's a bunch of helper functions in Framework that can help you do things like working with paths or building regular expressions and things like that. So definitely take a look around at what public API offerings there are in Framework, Vault SDK Framework, to sort of help you build your plugin. If you are developing a database plugin, it's important to use New Database Error Sanitizer middleware, a very, very long name, but basically it helps in case you accidentally log usernames and passwords that you're generating into your logs. It will help get rid of those. If you do have questions about this, I'm around after the event though. You can use Discuss or to look at our normal Vault forum, or open up a GitHub issue on Vault or the individual plugin that you are having trouble with, and we'll be happy to engage with you. All right. Thank you very much.